Okay, here's a method of solving these quadratic equations that will always work. Now, I don't recommend that this is your go-to method because it can be a little tedious. If you can solve it by factoring, or you can easily isolate your x squared and not have an x term in there, I would do that and use the square root property. Otherwise, we'll use the quadratic formula. Okay, it says that I start with ax squared plus bx plus c equals 0. Notice a couple things there. First, it's all in descending order. Ax squared, then bx with a single exponent, and then no x's at all. The other thing is that it has to be equal to 0. I cannot use this formula unless it's all equal to 0. If that is the situation, then these numbers in front, the a, b, and c, these coefficients, will help me find my answer. We know that x is going to be equal to, this is the opposite of b, plus or minus the square root of b squared minus 4ac, and notice it's all big long line divided by 2a. One thing I do recommend for sure is that this b squared, that you do that in your head. You know that squaring means multiplying a number by itself. When you multiply a regular real number by itself, that's always going to be a positive value. The other thing is this minus b out front here. Remember, that means the opposite of b, so that's not always going to be negative. Let's take a look at this example, and I think that'll illustrate it for us. We're solving this one for x. So 2x squared minus 4x plus 7 equals 0. First, identify a, 2. Okay, b, it's the number in front of x, including that sign, so negative 4. And then c is going to be this constant here, which is a positive 7. So if I put it in my formula, x is going to be equal to the opposite of b, so notice it's a positive 4, plus or minus square root, and then I take b, negative 4, multiply by negative 4, get positive 16, minus 4 times a times c, all divided by 2 times a. Okay, now it's just some arithmetic and multiplying stuff out. So you get 16 minus 56 underneath, which gives me a negative 40. Okay, here's a little bit of a problem. We noticed in the previous section that when I have a square root of a negative, that really means I have an imaginary number. So let's break down the radical on the side here. The square root of negative 40 could be broken down as the square root of negative 1 times the square root of 4 times the square root of 10. We can simplify the square root of negative 1 as our imaginary number I. The square root of 4 we know to be 2, and then our square root 10. This is still multiplication, and normally we put numbers in front of letters, so I'm going to write that as 2i root 10. And that's what shows up here in my next line. So I've got 4 plus or minus 2i root 10, all divided by 4. Now before I put that in as my final answer, I'm going to look at this and say, wait a minute, all these numbers out here, I don't worry about what's under the radical, all these numbers out here, they're all divisible by 2. If I can divide all three of these by the same value, I should do that. That's going to be my simplified answer. So that's where this final answer of 2 plus or minus I root 10 all divided by 2 comes from. All right, let's try another one. What if I have 3x squared plus 6 equals 10x? Well, the first red flag is, hey, it's not equal to 0. So that means we're going to have to subtract this 10x and move it to the other side. But I have to remember to be careful here, because when I move it to the other side, I have to keep my powers in order. So I'm going to put 3x squared minus the 10x, then the plus 6 equals 0. So then I can identify a is 3, b is right here in front of the x, the negative 10, and c is always the plain constant term of 6. Again, we put it into our formula, the opposite of b, plus or minus my b squared, which I did in my head, 10 times 10, negative 10 times negative 10, minus 4 times 3 times 6, all over 2 times 3. Do your arithmetic, and this time we get a positive number underneath our radical, the square root of 28. Okay, I didn't show you the scratch work here, but it's pretty easy. 28 is the same as 4 times 7, and I know the square root of 4 is 2, so that's where that 2 came from. Once again, all these numbers outside the radical are divisible by 2, so I reduce it. Okay, now I want to show you this really cool trick. I have just a minute here. If I take this, the one that's equal to 0, and I put that into my calculator, I can check my answer. So 3x squared minus 10x plus, oops, back up, plus 6, even though it's a messy looking answer, I'm going to check this. So I'm graphing it here in the standard window. And remember that if I set it equal to 0, then what I'm checking for are these intercepts. Well, I don't even have to go through and make the calculator find the 0. I'm just going to put in a value. So I'm going to work with a positive 1. I want the numerator here, 5, plus, and I'm going to use my square root key, square root 7, close up the radical, close up our numerator. I want all of that, that's why there's parentheses, divided by 3. Let's see what it tells me. Yes, y is equal to 0. Little hint, if the positive one works, the negative one will also work.